Not everyone on Earth thinks a manned mission to Mars is a good idea. However, I'm convinced that a manned mission to Mars would broaden our horizons and catapult us into a new age, both technologically and sociologically. When humans first set foot on another planet, it would be a symbol of progress, of overcoming obstacles that were thought to be insurmountable, and not least of the human pioneering spirit, an achievement that will be unparalleled. For a long time, people relied on a government space agency and, therefore, on politics. But today, a manned mission could also be carried out by a private company like SpaceX, in cooperation with NASA. Yet, before humans set foot on Mars, a whole series of probes will have to continue the exploration of the Red Planet. Even though an armada of orbiters and rovers have already explored Mars since the beginning of the space age, and the first images were generated of the Mariner 4 probe in 1965, there are still some mysteries. Still, the most important question is whether there is or ever was life on Mars, which remains unanswered to this day. For decades, space pioneers have dreamed of traveling to Mars, but it's only now we have the technical capabilities for such a mission, although there are still challenges that complicate matters. In this video, we want to discuss the biggest challenges of such a mission. 1. Size and power supply. The Mars spaceship, probably the Starship from SpaceX, is one of the most technically difficult and significant objects on a manned mission to Mars. It would have to accommodate 6 to 7 people for an extended stay, and would have to be equipped with at least enough space for the astronauts to get out of each other's way. It also has the possibility of participating in sports and entertaining those on board. A particular problem would be the energy supply, as solar panels would provide less and less energy since they're moving further away from the sun. 2. Cosmic radiation and solar storms. The Mars spaceship could have a special area for the crew shielded with lead, and it would be possible to store drinking and service water on the side of the spaceship to have further protection against cosmic radiation or solar flares. However, psychologists fear that if the astronauts had to stay in it for a long time, they might get cabin fever. A further problem of cosmic radiation is that through interactions with elements of the spaceship, many smaller particles with much lower energies are created from the particles of the primary radiation, called secondary radiation. This is why it might be necessary to protect the spaceship with strong magnetic fields. 3. Space farming. The quality of the food has a decisive impact on the performance and mood of the people on board. In addition, growing food in a small habitat on board the spacecraft could reduce the stress factor. 4. Waste management. Microbes, algae, and plants could help with waste management, and the astronauts' waste products would have to be collected and reprocessed. Unlike a space station in Earth's orbit, a mission to Mars would rely on a closed life support system. Everything must be reusable. 5. Muscle atrophy and weightlessness. Both the Mars spaceship and the later base on Mars could be equipped with a short-arm centrifuge, so up to 4 astronauts at a time could experience a higher gravitational force, at least for a short time. The head would point to the center and the feet to the outside, so that the greatest acceleration forces would occur at the feet. Furthermore, complex training patterns could be performed if it is also equipped with a bicycle ergometer and force plates. 6. Team spirit. When astronauts are crammed into a narrow spaceship for a long time, it's not only technical competence that plays a role, but social competence. Astronauts have to get along and depend on each other, as isolation from family and friends is a psychological strain. In the beginning, the crew would still be in the euphoria phase, which after a few weeks would be replaced by the routine phase. The strict regimentation through prescribed time schedules, the necessary fitness program, and the limited communication with the outside world could depress astronauts' moods, and low spirits could increase their susceptibility to error. Moreover, in the event of a propulsion system failure or the life support system, people would have to reckon with certain death with no chance of being rescued from Earth in time. 7. Communication. Communication would also differ from what we're used to on Earth. Due to the long journey and the increasingly greater distance, real-time communication would not be possible. Messages and emails would therefore have to be clearly written to avoid queries. 8. Medical care. Medicines would have to be produced on site, as they are difficult to store due to the higher radiation levels and would quickly lose their effectiveness. Furthermore, there would be a lack of medical facilities. You could have a surgical robot in the Mars spaceship, but it wouldn't be suitable for every medical emergency. All these things would not be easy to solve on the way to Mars and would be no less complex on the surface of the planet. One particular problem is landing on Mars because it's difficult to achieve even on unmanned missions, as the long list of failed missions show. The fact that NASA is more successful than other space agencies in this regard is mainly due to the fact that NASA has learned from its failures. Thank you for your attention. In the next video, we look at the challenges on the surface of Mars.